Hello, everybody, and welcome to the Astro Show, a place to be if you're curious about the cosmos. I'm your host, Dr. Sam, the founder and executive director of Wyoming Stargazing. Here, you can pick the brains of astrophysicists, get advice from a space doctor, learn about what astronomers have to say about life, and find out what's going on up above your head, all in the same place. Join us the second and fourth Tuesday of each month at 6 p.m. Mountain Time on Facebook, Twitch, and now YouTube as well. You can chat your questions on Twitch and YouTube, or you can call in and ask them live by using the login information on your screen. And we would love to hear from you. So please call in, ask some questions, make some comments, spice things up a bit for us. We're looking forward to hearing from you. In this week's show, we are going to chat with Dr. Amy Sardone, who is the NSF Astronomy and Astrophysics and CCAPP postdoctoral fellow at Ohio State University. Among other things, Amy studies star formation, and she will tell us all about that later on this evening. But before we introduce Amy, let's meet our co-stars. First, a huge shout out to recent, and we mean hours ago, doctoral graduate in astrophysics from the University of Chicago and host of her own YouTube show, Nora's Guide to the Galaxy. It's Dr. Nora Bailey. And Nora is not going to be able to join us this evening because she defended her dissertation and she is out partying as she should be. But she will be back in a couple weeks, and then all of us will be doctors on the Cosmos Show, which is very exciting. Nora joins the ranks of all of us who have spent many, many years, far too many, in school. But congratulations, Nora. We hope you're having fun, and we will see you in a couple weeks. Next, Director of Education and Public Outreach at the Vera Rubin Observatory, it's Dr. Lauren Corlees.
Hi, happy to be here.
Hey, Lauren. And next, medical doctor and founder of Orbital Biodesign, it's Dr. Danny Carroll.
Hi, everybody.
Hey, Danny.
Good to be here.
Great to have you. Last but certainly not least, also not joining us tonight because he's not feeling well, postdoctoral scholar from the Simons Observatory, Dr. Nick Galitsky. Nick, we hope you feel better soon, and we will see you in a couple weeks as well. So, Astro Advice is how we're going to start things off tonight, and we are doing that trivia style. So we've got one quotation and 4 potential quoters for you. And Danny and Lauren, it's your job to figure out who the correct quoter is. So the quotation is, be steadfast and unmovable in your dreams. Very succinct, to the point. I love it. Your 4 amazing people to choose from are A, Vera Rubin, discoverer of the Pulsar and many other amazing astronomical discoveries. B, Andrea Getz, recent physics Nobel laureate for her work on the study of supermassive black holes in the center of galaxies. C, Stephen Hawking, who really needs no introduction, renowned British physicist. And D, Stephanie D. Wilson, American astronaut. So ponder those 4 choices for a moment. And when you think you've got the correct answer, you can unmute yourself and cast your vote. You get a point if you get it right. And then we'll figure out who ends up with the most points at the end of tonight's show.
I'm not really sure who it is.
You both unmuted there simultaneously.
I was just going to say I'm not really sure who it is. I was kind of narrowing it down somewhat to either C or D. So I think I'll go with C, Stephen Hawking.
All right. one vote for Stephen Hawking, for Danny, and Lauren.
Funny because I was deciding between A and B. So either way, it's going to work out. But you can't put Vera Rubin up there and not have me guess her. So I'm going to go with Vera.
We thought we might bait you with that,
Yeah.
Lauren. that was bait specifically for you.
Well, I took it.
The correct answer actually is D. Stephanie D. Wilson, American astronaut. But nice try. No points for either of you on that one, but I like the way you were thinking. We think similarly, so that's I guess one step in the right direction. Any thoughts on Stephanie Wilson's comment there for us, her life advice?
I mean, I think it's generally, the life advice that I try and follow. There's a lot of people who try and talk you out of your dreams. And like there's no reason to let them do that. Like you need to believe in your dreams to make them happen. And so always having that belief in yourself is how to get there.
Nicely said.
I agree. I definitely echo that. And I think a lot of people will judge your dreams, or your aspirations a lot of times. And so even if, and I think judgment tends to be a little bit more insidious than somebody just outright saying, oh, that's silly, don't do that, but one way or another, I think Stephanie Wilson is spot on, that if you feel really called to go do something, then you should do it. So.
Yeah, agreed. I mean, that is really the reason why I got into astronomy education in the first place. It's what I love to do and couldn't really imagine myself doing anything else for a living. So far, so good.
Yeah, it's hard. And sometimes like you're the person who makes yourself unmovable in your dreams. It was hard for me when I was starting as an undergrad physics major, thinking, oh, I'm not very good at this. Like, this is hard. Like, is everyone smarter than I am? They seem to understand this better than I do. But then just deciding that was silly. I'm just going to keep trying my best and putting the work in. And here I am today. So it worked out. But yeah. Yeah, it's hard when you're the source of the doubt sometimes to try and power through that. So
I was certainly my worst critic for the majority of my life. Happy to say that I've grown out of that to a large extent over the years. But somebody pointed out to me years ago that that type of high standard that I was holding myself to was not only potentially a fault, but also had attributes of being some of my greatest strengths, because it gave me the motivation, the dedication to keep working really hard at whatever I was working on. So there are two sides to every coin. And fortunately, I think I was able to use that self-critical voice to actually work towards my dreams, even though it caused me a lot of stress and discomfort along the way. Ultimately, it was, as this mentor pointed out, it was also one of my strengths.
Yeah, you want to push yourself and always be making yourself slightly uncomfortable, because it means you're reaching outside of your comfort zone to grow. But you also need to be kind to yourself. It's really easy to judge yourself really harshly, and remember being able to let go of that and to
Yeah, that's a tricky part. Yeah, there's that zone of optimal development that you can get into with a little bit of pushing and shoving, but sometimes
it's trial and error.
Yeah. Just like everything else. Yeah. Danny, anything else to add?
No, I mean, I agree completely with what you guys are saying. So
cool. All right. Well, let's move along to Astro 365. And just a reminder for everybody out there, you can chat your questions on Twitch and YouTube, or call in, make a comment. We'd love to hear your thoughts on Astro advice and on stuff we're going to talk about during Astro 365. So reach out and at the very least say hello. So today is an important day in the history of space exploration. On this day in 1961, Vostok 1 was launched and Yuri Gagarin became the very first human in space. which is pretty incredible that was just 60 years ago. And we have come a long, long way since then. But pretty cool that we are celebrating that anniversary today. And there's going to be some news trivia that relates to that today. So, so get ready, Lauren and Danny, because that's where we are headed right now. And we've got Lauren signed up to go first today. You ready, Lauren?
Ready.
All right. So here we go. Question number 1. The Hubble Space Telescope confirmed that this object is the largest of its type ever discovered.
I did actually see this one. I know it was a comet.
Yeah, a comet.
But I know it was a comet.
Yeah, you are correct. That was the comet C2014 UN-271, also known as Bernard-Nellie Bernstein, discovered by 2 graduate students, actually, who are in totally disparate fields of research. Nice job on that, Lauren. 1 point for you. Number 2. The Herschel Space Observatory recently announced that messy magnetic field lines in this special region are contradicting established magnetic properties seen across the rest of the Milky Way galaxy. The name of that special region is what we're looking for.
I don't know the name of this special region, but this is an interesting result because whenever you don't understand something in astronomy, you like to just blame the magnetic fields. So if even they are complicating your understanding, that's not great.
If you don't know the specific name of the region, if you give us the general name of these regions, we'll give you a point.
I'm gonna take a guess here. Is it a star forming region?
You are very close.
Okay.
They're called galactic bones.
Oh,
I
interesting.
didn't even know these things existed.
Yeah.
This is galactic bone G47. And these are these long filaments of gas and dust that form down in the middle arm of our galaxy. Galactic bones. So I think technically they do contain star forming regions, but they're larger than just one star forming region.
Like a bigger
themselves.
Complex.
Yeah.
It's a great picture. Yeah.
It's a cool picture, isn't it? Yeah, super cool. And you can see all those twisting magnetic field lines that are in every which direction. Okay, number 3. NASA's Chandra X-ray Observatory has captured images of 14 supermassive black holes in the spiderweb protocluster, feasting on nearby material during a time when the black holes and galaxies they inhabit underwent extreme growth. That period of growth occurred about 3 billion years after the Big Bang and is nicknamed what?
Oh, this one I feel like I should definitely know, but the name is completely escaping me.
It's a simple one. It's not morning. It's not evening.
Oh, cosmic noon.
Cosmic noon.
Yeah, I did know it. Thank you for the hint.
Nicely, we'll give you that.
No, I know this.
one point for you.
Yeah.
Okay, next question. This was another new one for me today. The terms black widow and redback refer to what type of extreme space-based object?
Are these pulsars?
They are very specific types of pulsars, though. You know which specific type?
I should do, because I feel like I shared an office with someone who worked on these, but I don't remember. It was like a decade ago at this point. No, I don't remember.
They are binary millisecond pulsars.
Oh, cool.
Also, the hint I was going to give you is that we were going to refer back to a part of the previous question. These are spider pulsars, their other name, thus the black widow and redback.
Right. Yeah. Cool.
Yeah, spider pulsars. Really, really cool objects. So these objects are spinning in less than 0.003 milliseconds. These are fast spinners. And one of them is losing mass and being sucked up by the other one. Pretty cool objects. Okay, your last question, Lauren. Former astronaut Scott Kelly just created his first of these to help support Ukraine.
was an NFT, right?
Yeah, you got
Yeah.
it. Yep, these non-fungible tokens. And in this case, they're his pieces of artwork of himself up on the ISS. This was my favorite, which is him wearing a gorilla suit, which he actually did aboard the ISS. So very cool picture and very cool idea. I don't really know much about these NFTs, but apparently they are all the rage.
I like the suggestion that there's a future trend where you can have customized spacesuits. You can be a gorilla, you can be whatever you want in space, not just an astronaut looking person.
All right,
I'm sure that
Lauren.
was the most
go
expensive
ahead, Danny.
gorilla suit. I'm sure that was the most expensive gorilla suit.
I'm just like wondering how he convinced NASA to let him take a gorilla suit into space. I mean,
I kind of love it.
I thought you got like one tiny little bag of personal items that each astronaut would get. Like, you know, what like incredible space experiment got turned down for Scott Kelly to bring his gorilla suit to space?
If you get to go for almost a year, you get to make a bigger request.
I guess so, right? Yeah, when you're going to spend 340 days on the International Space Station, I guess they let you take up whatever you'd like. Well, Lauren, you got 4 questions correct. So you're in the lead with 4. So Danny, you gotta get all 5 here.
You can do it.
In order
I believe in
to
you.
be our champion this week. All right.
Oh boy.
No pressure. All right. You ready?
Mm-hmm.
Okay. Upcoming ISS mission specialist Eitan Stieb is slated to perform an experiment to harden a liquid so that it can be examined and tested by researchers back on Earth in hopes of making what?
May I have a hint, please?
It's something really, really big. It'll be the biggest of its kind, either on Earth or in space, by at least an order of magnitude.
Oh,
And you can,
I don't know.
It's up Lauren's alley of stuff that she works on as an astronomer, but way bigger than what she's working on. Way, way, way bigger.
Like star size? I don't know.
Not star size. Not that big.
I don't know.
This would be a liquid mirror telescope. Yeah, so astronomers have figured out how to make these liquid lenses. And so this experiment is going up to the ISS. They're going to do a bunch of testing with these liquid lenses. And then they're going to harden them using UV light and some other apparatus. And then we're going to return the solid liquid lenses back to Earth. And they're going to be undergone different amounts of tests. And it'll be the first of its kind. It'll be the first ever telescope mirrors made in space. So kind of a hallmark study happening this week.
So cool, because right now we're limited by what you can actually put in a rocket and launch. And even on the Earth, you're limited by what sort of weight you can support and move. So being able to build something just massive in space would be incredible.
Yeah, gravity and mass are the limiting factors. But if it's a liquid and you're doing it out in space, there are really no limits. So yeah, it's pretty cool idea. Yeah, so we're talking about mirrors, you know, hundreds to thousands of feet across. Really, really big telescope mirrors.
Oh,
it'll be very cool. All right, next question. This week, ESA's research and development team crafted this early step towards revolutionary emergency spaceflight medicine.
Early step.
Yeah, apparently this was the first one of these that was made on Earth that will have applications in spaceflight medicine.
I don't know.
Okay, I'll give you a hint. It's has nothing to do with muscles, but rather with
Bone.
Yep, the first 3D printed bone.
I mean, in space or period? Because it's been done on Earth before.
apparently this is the first one that has applications in space. I'm not sure why this one was special, but
I'll go read about it.
Yeah. All right. Next question. Today, on the anniversary of Yuri Gagarin's historic first human spaceflight, the company Space Perspectives announced what?
You're killing me with these questions.
Oh no! So they're in the same industry as Blue Origins and SpaceX and Virgin Galactic, but they're doing it a little bit differently.
I don't know. I mean, it sounds like, so they're, I've not actually heard of Space Perspectives before. I've obviously intimately familiar with like SpaceX and VG and Blue, but
yeah,
I don't know.
These guys were new to me as well. They are going to launch a gigantic balloon that will bring tourists up into the stratosphere, about 100,000 feet up in this luxurious space. They've got two different models, but complete with bathrooms, lounge chairs, a little mini fridge of everything you might want to imbibe on your flight up, which takes about 2 hours, and then a very slow 2-hour flight descent back to Earth. Yeah, it'll be one of the largest balloons ever created.
Wow.
Yeah, and they're planning to launch the first one in 2024, so it's coming up.
Interesting. Cool.
All right, next question. Which country has signed a contract with SpaceX to launch 5 spy satellites by 2025?
Got any hints for me?
It's not China.
Do you know these answers, Lauren?
And not particularly a country that we have in our good graces either.
Oh, Russia?
Not Russia,
Oh, okay.
but previously not in our good graces.
I'm not sure.
It would be South Korea.
Oh, interesting. Okay.
Yeah. All right. Last question, and then we'll let you out of this. In a study published today, researchers found that long space flights lead to swelling in these compartments that surround blood vessels in the brain.
So they're compartments that contain cerebrospinal fluid. I don't know if that's what they're referring to, but we already knew that.
Yeah.
So is that what you're getting at?
They use a slightly different term, but I think it refers to the same thing that you just mentioned. Mm-hmm. Is there another name for those spaces? Well,
so there also are lymphatic vessels. There's a lymphatic plexus in the brain that is thought to be involved in some. It's one of the pathways toward the development of spaceflight associated neuroocular syndrome, SANS. I don't know. I'm not sure what they're specifically getting at.
These guys were talking about perivascular spaces.
Oh, that literally just means the space around blood vessels. Okay. Yeah. Okay, well.
We're going to give you that one because you used a bunch of language there that was way above my head. So
I think Lauren still won. Good job.
Yeah, we asked you some hard ones there. Way to stick with it and get that last one. And we had some doozies for Nick and Laura as well. Excuse me, Nick and Nora. Yeah, they weaseled their way out of it this time, but we'll get them in a couple weeks.
Nora got asked enough questions today, I'm sure. Grilled during her defense.
Yeah, she got grilled today, so she's off the hook. I did offer up the opportunity for the co-stars to hit me with questions pertaining to current space news. So if you got anything, you're welcome to try to throw me under the bus as well.
I do. I have one.
Okay, please.
So, all right. So tell us about the launch that's happening on Friday. who's on it
Ooh.
and what's the name of it and all that
Well, this
stuff.
was, I believe this was supposed to be the first test flight for Artemis 1, right? No, not the Artemis test flight. Is this the next Crew Dragon capsule?
It is.
That one. Okay. Oh, you want the names of the people who are on it?
Oh, well, so it's Crew 4, but
Oh, Crew 4.
sure.
Crew 4.
Yeah, if you can, do you know who?
Nope, sure don't. But I think one of them was in one of the questions that I asked about, right? Who's going to be doing that experiment on those liquid telescope mirrors? Eitan Steib, right?
So for the NASA launch, it's Chell Lindgren, Jessica Watkins, Farmer, I'm blanking on his last name, and an Italian astronaut. So those are the 4.
Nice.
Yeah.
Excellent. That was a good one. Lauren, you got anything for me?
No, I'm sorry, I didn't remember this week. But next week.
That's right, Daniel. I gave you lots of hard questions, so if you got another one, you can feel free to hit me up again.
Okay.
All right. But yeah, that is. Let's see. Is this the first full? It's not the first full commercial launch, or is it?
No. So Axiom launched a few days ago.
Axiom.
And so that was Axiom 1, and they're on the ISS right now. So that was a full.
That was the first
crew.
commercial one.
Mm-hmm.
Yeah.
To go plug into the ISS. And, yeah.
Right. Cool. And so, are those folks coming down now this Friday when Crew Dragon goes up?
I'm actually not sure when the Axiom crew is slated to return. I'm not sure what part of that, that piece of the plan, but yeah, I guess we'll find out.
Well, we will indeed. Oh, I forgot to mention that fluidic space telescope mirror has a very lovely acronym. It's the Fluidic Telescope Experiment, which I guess is going to be performed this week on the ISS. It's called FLUTE, Fluidic Telescope Experiment, FLUTE. Love those acronyms that astronomers come up with. All right, well, we have come to that point in our show where it is time to take a short break. And when we return, we will be here with our special guest, Dr. Amy Sardone. So don't go away, get some refreshments, and we'll see you back here in just a few minutes. Welcome back, everybody. Samuel Singer here with the Astro Show. Excuse me, almost called it by our old name, the Cosmo Show. Welcome back to the Astro Show. We are here with Dr. Amy Sardone, who is a postdoctoral fellow at Ohio State University. Amy, thanks so much for being here.
Thanks for having me. I'm excited to chat with you all.
Excellent. Likewise. Well, we like to start these chats off with the same question for everyone, which is, what's the one question that you wish everybody asks you, but nobody ever does?
Okay, so I think this is a hard one. And what I can come up with is, when was the first time you met a scientist? Maybe like how old were you when you met a scientist? Do you want my answer?
Yeah, I mean, I'm curious why you came up with that, and yeah, and how that influenced your life.
So I was an adult when I met my first scientist. I was just out of college, probably a year or so out of college, and it was a big influence for me. I'd never met a scientist in my mind. Like, doing any kind of science was something that's very abstract or something that people do on TV. And I think, right, yeah, exactly. Seeing someone and meeting them and talking to them, it kind of brought it into a realistic or really like an attainable goal. And then I changed trajectories for my career and became a scientist.
Oh, so who was the scientist that you met? Do you remember?
Yeah, so my first career was in music. I was a music teacher, so I was teaching voice lessons to his son, and his son told me, "Oh, my dad's an astrophysicist," and I was like, "What?" Yeah, so it was my student's dad.
Oh, very cool. Very, very cool. And are you still in touch with him?
No. After I quit teaching music, it's kind of fallen away.
Okay.
He did help me go and see the McDonald Observatory in Texas a couple times. He like put me in touch with astronomers so I could get a really good tour.
Very cool.
Yeah.
Yeah, that is definitely one of the observatories on my bucket list. That's where they produce Stardate, the NPR show. And so, yeah, I'd love to go check that place out at some point.
Yeah, it's very pretty, and the town is very cool, and it's near to maybe like 20 minutes away from another really cool like art town, surprisingly, out in East Texas.
What's the name of that?
West Texas. Sorry.
What's the name of the art town?
Marfa.
Marfa. I have heard of Marfa, Texas before for that reason, that it's this like artsy like oasis in the midst of something very different.
Right. Yeah, and we just happened upon it when we were visiting. Went to a restaurant and it was really expensive wine list. We were like, where are we?
Yeah, I've heard it. Yeah, it's a bit different than everything else around it.
Yep.
Cool. Okay, so you were a music teacher. You met this astrophysicist. Why did you then decide to become an astrophysicist?
I think it's kind of a boring answer, just that I thought like that sounds really cool. I like astronomy. Astronomy is very interesting, and I would watch like discovery shows and learn things about space from TV, basically. And when I realized that you could actually be an astronomer, that I just decided that's what I wanted to do.
Wow. So did you have those interests as a kid or as an adult, or no?
Yeah, just as an adult. I was never even into math. So when I switched, it was really a matter of wanting to do it and putting my mind to doing the math. And it made the math interesting and challenging in a fun way. Whereas before getting my music degree or in high school, there was nothing fun about it. So it wouldn't have worked back then until I had changed my mind.
Yeah. So that's all that changed for you. Just the fact that you were having fun with the same kind of math content that you didn't enjoy before, or inspirational teachers, or
after I had decided to switch careers.
Yeah.
Sorry, I guess I don't understand the question.
Oh, sorry. I mean, you mentioned that the same, math that you didn't enjoy and didn't find interesting in high school, you really enjoyed when you were on your way to become an astrophysicist. And I was curious if it was just a mindset change for you, or whether there were teachers that were inspiring as well while you were, on your journey to become an astrophysicist, or other factors that influence that math that be interesting for you.
I think a lot of it was a mindset change. It was suddenly very interesting, and I knew I needed to know the math in order to to achieve this. And so the math became an interesting problem. I did take my first astronomy class was at a community college, and I wanted to, see what it was all about. And I had a really good teacher, and it, of course, came with a really good lab, which you get to do all of these cool experiments. And I think that was a good like foray into actually making a decision about pursuing it further. Community colleges are pretty great.
Yeah, they definitely are. So you went and got a PhD in astrophysics, and then how did you figure out what you wanted to study in astrophysics?
I was presented with some different projects, and I picked the one that was the most interesting to me, which it had to do with star formation. Yeah, I think as a grad student where I was, there was a few paths to take. When you go to grad school, it's obviously you can't just like pick literally anything under the sun. You have some projects that you can choose from, and I'm really happy that I ended up picking the one that I did, because I think it's really interesting.
So tell us a little bit about that.
Yeah, so my work is broadly about galaxies. Basically, if it has anything to do with galaxies, I'm curious about it. And my expertise is in nearby galaxies. So I've looked at a range of galaxies, from like the smallest dwarf galaxies, which help us understand a little bit about dark matter. I've looked at Milky Way type galaxies, other types of spirals and other massive galaxies. And then some galaxies that are so actively star forming that they have material being ejected out of their core into the surrounding medium. In particular, one of the areas that I'm interested in is how galaxies form stars. And of course, that's not to say that we don't know anything about how galaxies form stars, right? But there's still some really big open questions, and some theories basically that we haven't been able to observe yet about star formation. So for example, if you think about the universe like a timeline, so we start 13.8 billion years ago and we end at the present day, you would see early on the universe was full of gas, and then some time passes and that gas clumps together and forms these bigger clumps, and those clumps turn into stars, and those stars clump together and form galaxies, and then of course they grow into the more massive galaxies that we see today. And if the puzzling part, and this is the part that I was presented with as a grad student, is if stars are formed out of gas, and then billions of years have passed since that whole process began, we would expect for all of the gas to have been consumed by now, right? So instead, of course, when we look around us, we see galaxies that are actively forming stars. Everywhere we look, we see star formation in galaxies. So what we want to know is what's the fuel that these galaxies are using to make new stars. Basically, there should be no gas left over after this many years of galaxy evolution. But we are actually seeing these really big reservoirs of gas around the galaxies. And that's kind of puzzling. So some very sophisticated simulations of the universe have basically posited that the reservoirs and the continuing star formation are a result of the constant fuel supply to the galaxy. So we picture this fuel supply like a giant web, right? Which we call, this is the cosmic web. And this basically tells us that every galaxy in the universe is connected to another galaxy. And the web material that's connecting them through these like filamentary structures is made up of gas and dark matter. And that's feeding the galaxies. It's continuing to fuel the star formation even now after billions of years when it should have run out. So the work that I do is because the web is extremely diffuse, and obviously that means that it's very, very dim, and we have a really hard time detecting it, and it's basically only been detected indirectly. So I use a really big radio telescope basically to try and detect the diffuse light. And of course, the bigger the telescope, the more sensitive you are. You collect more photons, and you can hopefully detect the really diffuse stuff that's out there. And specifically, the most abundant element in the universe, which of course is hydrogen, is the element that we expect to see flowing along those filaments, and that's the gas that eventually turns into stars. So that's what we look for, and we look for it in the radio because the hydrogen line is emitting at radio wavelengths.
So is
That
this
was a long spiel, sorry.
no, that was fantastic. That's super cool. So this hydrogen that forms the cosmic web, this is the original hydrogen left over from the Big Bang, or is it hydrogen that's been recycled through generations of stars that have exploded a long time ago?
Right, that's a good question. We know that it is not from exploded stars because it's pristine. It's basically mostly hydrogen, maybe a little bit of helium, and very little metals. So this is what you would get after stars explode. When you know something is from an exploding star, if it has a particular kind of metallicity. So yeah, it's the remnants of the past.
Very cool. So what kind of state is your current research in with being able to detect this cosmic web?
So there are lots of surveys that I'm a part of where we basically try and look at a bunch of different galaxies that are surrounded by other galaxies that are isolated, little galaxies and big galaxies. This sounds like a Dr. Seuss book. Basically, we're trying to
probably should be, actually.
Right. We're trying to capture really the whole gamut, and we point our telescopes at them for a very long time, and we hope to detect diffuse emission from the hydrogen. So one exciting project that we've done recently is with a grad student at Ohio State. Her name is Sanskriti Das, and she has published some detections of gas that is pretty far from the galaxy in terms of within where you would expect the dark matter halo to be. So the dark matter halo is kind of what we call, it's basically the boundary of the galaxy. There's the light where the galaxy is, and then there's the region around it where the dark matter halo is. And we expect to see little galaxies in there that are satellite galaxies. But beyond that, that's where the accretion from the cosmic web should flow through until it hits the galaxy disk. So it's been very difficult to detect hydrogen at large distances from the galaxy within the dark matter halo. But she has successfully done this, and she has a big program with the Green Bank telescope that is looking at a whole bunch of different galaxies and at a whole bunch of different areas around the galaxies so far. It's so far been pretty positive results. Another thing that I have been working on is looking at a bunch of nearby galaxies, and we really are staring at the galaxies for a very long time. And what this does is it helps you to collect more light from the diffuse parts of the area around the galaxy. And that is, of course, in hope to detect some filaments, basically. So
Very
that's
cool.
a work in progress.
That's fantastic. I don't know how I haven't heard of this before, but thank you for enlightening me.
Sure.
Lauren, Danny, any questions for Dr. Sardone?
Given her Alex, it's super hard. The gas is really faint. It's hard to detect it. So I guess I was wondering of how optimistic are you for detecting it? It feels, yeah, I guess that's my question is, yeah, what do you think the success is going to look like?
Yeah, I think as a field, we have been kind of moving toward bigger and bigger telescopes and longer observations, right, in effort to detect this. So we reach a certain level where we understand that we're not detecting it at this level. So we need to go an order of magnitude deeper, basically. And so we're at the, we're just at the next level. We kind of have well, not kind of, we have an idea of where exactly at which level to look. Because we have some indirect studies where the Hubble telescope has basically pointed near a galaxy. So here's our galaxy, and we're pointing like right here. But in the background, there's a really bright quasar. So you get an absorption feature if there's some gas like right here, right? So you have an idea about what level of detection we would need to detect that kind of gas. It's frequently very low, and you can get that number from the absorption spectra indirectly because it's just telling you, like how much is being blocked, right? That's what the absorption is. And so what we're looking for is emission, and we want to see the direct signature of it, and we want to map it out and see exactly where it is. And we are trying to go farther and farther down to get to that level. And I would say we're close. And it's possible at the levels that we are doing our surveys, particularly this one survey where we're really just staring forever at these galaxies. I think we have a pretty good chance of mapping something out. But then, of course, we also have really big telescopes that are being built right now. We have the new Meerkat telescope that is in South Africa, and that is able to look at kind of larger regions of the sky at higher resolution. So the potential for this is good in the future.
And then my other question is, I guess, how good are the instruments? Because at some point, at least I know in the optical, you can reach a point where the emission you expect isn't brighter than the noise the detector itself creates. So like the detector in like your phone or whatever is generating electrons, which it registers as a signal that's brighter than what is coming from space. But I don't know what that's like for radio. If like, yeah.
It is a problem for radio, of course. Like your cell phone is a problem, and so the telescopes that we use are obviously very they're in remote places. The closest one to us is the Green Bank telescope, and that's in the largest national quiet zone. So there's a good amount of like their neighbors can't even use a microwave.
Wow.
Wi-Fi, right?
Wow.
So there's definitely no Wi-Fi. There's no cell phones, right?
Wow.
So these these people have chosen to live within this boundary of the quiet zone. But so the radio frequency interference is an issue, but the L band, which is at 1.4 gigahertz, where we see the hydrogen line, is in a protected zone. So you shouldn't see cell phone signals, even if a car drives by. They don't know they're in the quiet zone, and the cell phone is around, and that would be a huge problem. But there's a protected region in this L band where RFI should be limited. It's a good question because it is a real problem, and we will run into the limit of the telescope. So
it's the same sort of issue of like the satellite constellations that they're launching being the sort of like optical noise we have to deal with, that you can also have this radio noise that is encroaching in astronomy and the observations you can make. So
right.
Yeah, that's exactly where my mind went as well, Lauren, like if we can have these like protected zones in the radio wavelengths, why can't we have them in optical as well? Like, and there just shouldn't be any optical noise and in certain parts of the spectrum. Wouldn't that be sweet?
Yeah, I agree.
Well, it's cool that there are actually bandwidths that are protected that way. I had no idea.
Yeah, there's a few, and they do get smaller and smaller. So, you know, there are people that work on making sure it doesn't go away, but it needs to be protected.
Yeah, yeah. One of the things that I'm working on is protecting dark skies in Jackson and Grand Teton National Park. So we're working with the town council and the administration in Grand Teton to try to create some better legislation that can protect the parks locally and then get the city and the park recognized by the International Dark Sky Association as a dark sky park and dark sky community. And hopefully that will just help convince the folks who live there and the folks who visit there to be more conscientious about turning off lights when they're not using them at night.
Yeah.
I've got a question, if you don't mind.
Yeah, please, Danny.
So Amy, that was a fantastic talk. It was really, really interesting. And I'm just curious if you could talk a little bit more about what you plan after finishing up the postdoc.
That's a good question. I don't know exactly. So I have a TwoBody problem. So my partner is also at Ohio State, and we love it here. And I love the department that I'm in, and we actually really like Columbus too. So we're gonna try and stay. So one of the kind of immediate things that I'm going to do is likely stay on in the department as a department postdoc after my fellowship ends. So they've been really, really friendly and generous, and have tried to make it so that they're helping me solve my TwoBody problem.
That's awesome.
Mm-hmm.
Yeah, you reminded me, Amy, of a conversation that I had with my astronomy mentor in college. I think he was the first person to introduce the problem in physics, the ThreeBody problem, where you can't use one set of gravitational equations to solve for the positions of three gravitational bodies. And he only told me that because he and his wife were looking for permanent positions at a university together. And he said, the real problem is not the ThreeBody problem, it's actually the TwoBody problem. That one is way more pertinent for way more people. So I get it.
Yeah.
I don't want to spin you off in a different direction away from astrophysics, but I'm curious about whether you miss being a music teacher, and if you think you've got music in your future, or whether you're still doing some of that now.
I'm not doing it right now. I actually continued to teach a little bit on the side all the way through grad school, and up until I started my postdoc. And it was hard to let go. I think I hung on to like one student for a while, because I do really like it. It's really fun to like interact with little kids and see them, you know, enjoy playing music or singing. And my kids are interested in taking piano lessons, and so occasionally we'll sit down at the piano and do a lesson. But of course, you know, I don't do it weekly like I should.
Yeah, that's hard. My mom tried for years with me, and I didn't practice as much as she wanted me to either.
Right? Who does? Yeah. So, you know, I won't get back into teaching unless it's my kids, probably.
Yeah, nice. And I understand that you've got a couple other hobbies as well. One of which you picked up during COVID, and one that I think you've been doing longer than that.
Let's see. Well, the hobby I picked up during COVID was woodworking. And I don't know why. I actually think quite a few people picked up woodworking during COVID. I don't know what the appeal was exactly for everybody, but yeah, I mean, I got a bunch of like saws and clamps and things. So I've actually just built a kitchen island with my dad. My dad came into town and we built this together. And that was kind of like my biggest project that I've done so far. So that's pretty fun.
That's awesome.
Yeah.
You have another project in mind now?
I think the next thing is going to be building things for the workshop that makes the woodworking easier.
Oh, nice.
building more tables and things to set my saws on top of.
Very cool. That sounds awesome. And then you're also a knitter, right?
Oh yes, I do crochet. It's always a very slow process for me. I seem to pick it up in the winter and put it down in the spring. So it's a short season. Yeah, I have a little bit of knitting. As long as it's a square, I can knit it. I have not had a lot of interest in following patterns or doing anything more complicated than like scarves and blankets. So yeah.
Nice. Well, Amy, we've got just a few minutes left. Anything that we haven't already chatted about that you want to share with us, or do you want to leave us with some profound thought that you have, or just a non-profound, just interesting thought?
Is it okay if I tell you about one other project that's not
Please.
related to our formation?
Totally. Yeah, of course.
Okay, so I've been working on this this other project with somebody at OSU where we look at little galaxies, basically like the smallest galaxies that we can find. They have very low stellar masses, and kind of the point of this is to get information about dark matter. And what we know about the cosmological model that everybody agrees upon is lambda CDM, which is dark energy, cold dark matter, and then ordinary matter, and that's what the universe is composed of. But it works really, really well, of course, but except when you get down to really small scales. So it works really well when we're talking about dark matter in big galaxies and Milky Way type galaxies. And then for the smallest galaxies, it just doesn't line up. There's a discrepancy. So one of the things that we want to look at is what can we see about these smallest galaxies that can narrow that gap and change the discrepancy. And so in order to understand dark matter in the galaxies, you have to look at the kinematics. So we basically, if we want to talk about Vera Rubin again, Vera Rubin was the one who basically figured out that the speeds and the orbits of everything inside the galaxy should be different than what we see. And what we see tells us that there's dark matter, right? So, the orbits at the edge of the galaxy should be going a lot slower than the orbits near the center of the galaxy. And she showed us that these orbits are actually going at the same speed. And this tells us that there's some kind of mass that we don't see that is making it so that these speeds are essentially all the same. And so, of course, that's the dark matter. And so in little galaxies, we use the speeds to understand how much dark matter there is. And lambda CDM, our cosmological model, tells us that there should be tons more of these dark matter halos for the small galaxies. And it works really well with the larger galaxies, but then with small galaxies, we don't find the numbers. They're just not there. And so one of the things you can do is you can kind of measure the rotation velocities in these littlest galaxies and see if they line up. So that's a project that we're doing again with a radio telescope, and we're looking at hydrogen, because hydrogen can also tell you about the velocities of everything in the galaxy. And It's interesting results. So we'll have a paper coming out soon about that, where I think we're actually closing the gap a little bit more for that discrepancy between the dark matter and the small galaxies. So I'm excited about that. I think it's a cool project, and really, I mean, my field is not exactly dark matter, so I'm always excited to do something different, especially if it has to do with dark matter.
Awesome. Well, I'm looking forward to seeing those results.
Thanks.
Any last thoughts you want to leave us with?
Well, I guess I would go back to my answer to your question about the question earlier, and you know, I hope that your show is helping to expose people to scientists and expose them to scientists earlier on in their lives, and I'm happy to be a part of it. I appreciate it.
Well, we're psyched to have you. I have the same hope for the show, and so yeah, I hope it does, and I hope this episode is no exception. So yeah, Amy, thank you so much for being here and for your time. We really appreciate it. We've got a thank you gift for you, and Maggie will follow up with you about that. So again, thanks so much. Thanks to our co-stars, as always, for being here. Wouldn't have this show without you, so thank you so much. Also, thanks to Maggie, our Director of Operations, and Gavin, our voice behind the curtain stream master, who makes this show possible for us, as well as the Board of Directors of Wyoming Stargazing, and all of you out there who are watching. We really appreciate you tuning in. We want to hear from you. Give us a call, send us your comments, and we will see you on the next Cosmos Astro Show in a couple of weeks. I'm still need more time to get used to that, apparently. But until then, be well, and don't forget to look up. We'll see you next time. Bye.